Hello, welcome to Introduction to Java Programming. In this session, we will discuss about interfaces in Java. Let's begin. Interface in Java is a keyword, and it's just like a class. That means it is also a reference type, and which is going to have all abstract methods only. So interface is a reference type, just like a class, which is going to contain all abstract methods only. So there are no constructors, there are no data members, and there are no concrete methods. All are going to be abstract methods only. And of course, while using interface, we also use one keyword that is called implements. The class that implements the interface will use this keyword. So we will see that as part of the programming. So interface contains only abstract methods. We know abstract methods are the methods which have no body, and interface can contain constant values. Constant values are final members, right? For example, final some double pi equal to some 3.14. So like this, I can define a constant in an interface, only constants. And the next important thing is, in the interface, all the members, whether they are abstract methods or constant, public by default. They are public by default. Okay, so if I write a method, that will be a public method. If I write a constant, that by default public, because they have to be implemented by somebody else. And interface achieves 100% of abstraction, right? Through interface we can achieve 100% of abstraction, because it has all specifications only. There is no concrete things, there are no implementations. And just like abstract class, interface cannot be instantiated. So you cannot create an object for an interface, right? And just like abstract class is extended by some other class, so here when you have an interface, when you specify the functionalities, and if somebody wants to have that, and that particular class, there should exist a class that implements the interface. So here the keyword implements comes, and provide implementation for all the abstract methods. Now the class that implements the interface has the responsibility of implementing all these abstract methods. If the class fails to provide implementation for at least one method, then it also should become abstract. A class implements interface and it is failing to provide implementation for any one of the abstract methods defined as part of the interface, then this class also should become abstract. Okay, and interfaces can extend each other. Okay, so that means there exists inheritance among the interfaces. One interface extends other interface, something like that. Okay, so this is the theory. So if you understand abstract class, understanding interface is very easy, because we have seen programs in the abstract class, and we have written implementations, we have created objects of the implementation class which are being referred by the parent types. The same thing is going to happen here also in interfaces. Okay, so to sum up once again the theoretical part, interface is a class type which has only abstract methods, and if you wish, we can actually have some constants also, and all these members are by default are going to be public, and they can't be instantiated. So there should exist a class that should implement this particular interface and provide implementation for all the abstract method. If the class fails to provide implementation for at least one of the methods, then that class also should become abstract. So with this, let's go ahead with the programming. Now I have the class called RBI. So let's assume I have the class RBI. So this is an interface, so we will have all abstract methods. Since all are abstract methods, since all are abstract methods, we need not to write them abstract also. We need not to write them abstract also, right? So I need not to say here abstract, because by default all are abstract. So the compiler, what it will do is it accepts whatever you write and later it add abstract to that. Okay, and all the members are public. So not only just abstract, the compiler will add public also. Public abstract void withdraw, something like this. So in the same fashion here, public abstract void deposit. So that means the compiler make these methods added with public and abstract. And here this is a constant, right? So whenever I say constants, I have to give the value. So let's say the value is 8.5. Every constant must be initialized, otherwise it cannot be a constant, right? I need not to say final here, because by default all the members are going to be final. Okay, first of all they are public and they are final, and any final member is actually treated as static. Any final member is treated later as final static, because these constants are going to be stored in the class area. So a final member underlyingly will become final static. Okay, so it will be like this. So it will be public final static in int rate. So int rate equal to 8.5, something like that. It will be rewritten. Okay, so this is my interface. So public interface RBI. I have one constant and two methods actually, and by default they are abstract methods. And if you want many methods, we can write also, let's say void transfer. So we just need to write void transfer. Automatically this will become like public abstract void transfer. Let me show these basic details first. So I have saved this as rbi.java because it's like a class. It's just a class only. Interface is also just like class. So I can save it as rbi.java, and when I compile java c rbi.java, then I will have the bytecode generated and printed. Java c rbi.java and bytecode generated. So now if you want to see java p rbi, let's observe actually. So whatever what we have written and how it got changed. See, even though I have written public int rate, it became like public static final double int rate. Okay, so these things got added automatically by the compiler. Okay, modifiers can come in any order. It can be public static final, or it is static final public, whatever the order it is. And when I say withdraw, it became like public abstract void withdraw, right? So this is what actually is going to happen for all the things which you write in an interface. So we need not to write final or public or abstract. All the members are by default public, and all the methods are by default abstract, and all the data members that you declare by default are going to be constants. So they are public final static values. So this is the basic specification in the interface. So interface achieves 100% of abstraction. If you see here, all are abstract methods only, no implementation. So 100% of abstraction. Now RBI specifies these are the functionalities that should have for an ATM if anybody would like to have. So now SBI, there is an SBI bank, and SBI wants to have the ATM. Now what SBI will do? SBI is interested in ATM, so it will approach RBI and says, I want ATM. So RBI then says, okay, fine. So these are the functionalities, we implement it. Okay, so now there exists a class that is SBI. What should it do is it should implement. So there should be a keyword called implements RBI. So now it is the responsibility of the SBI class to provide implementation for all these methods. So all these methods implementation has to be provided. Okay, otherwise it also should become abstract. Otherwise it should also become abstract. So an empty implementation is also an implementation. We know that. An empty implementation is also an implementation. Yeah. So here I can do like this. I can do like this, but there is an error actually. There is an error. So I'm just saying void withdraw. Empty implementation is also implementation, but this withdraw method is a public method, right? In the RBI, if you see, it is public method. So now what I'm doing, I am actually making default. Okay, so that means I'm weakening the privileges. So if you try to compile, right, so now you will get that particular error. Let's see this error. When I say Java C SBI.java, now what happens, you see? Yeah, transfer in SBI cannot implement transfer in RBI because we are attempting to assign weaker access privileges. Was public. So the transfer method or withdraw method or deposit method, they are all public. What I'm doing, I'm attempting to assign weaker access privileges. So I'm not specifying anything, that means default. So default is weaker than compared to the public, right? So public has highest access, right? It can be accessed from anywhere. It was public, but I am actually making it default. So that's why that error. So this is one common mistake actually, because when we specify interface, we will not specify public or abstract. By default, they are public. So that's why when you implement, you forget that, but one should not forget that actually. Otherwise, we are going to get a compile time error. Okay, so public void withdraw, public void deposit, public void transfer. So empty implementation is also an implementation. We know that. And let me compile this. So Java C SBA.java. Now there is no compile time error, but I need to provide something. So what I do is I just write few things here, system.out.println. So now I am saying withdraw success. It's a withdraw method, so I just want to write one line. So withdraw success, and here also I can have one PL statement. So where I'm saying deposit success, and you got interest at what is the interest actually, right? So we have the interest rate, right? So from the interface, I can actually access the interest rate which is defined. So I can actually say int rate. So whatever the int rate was given over there, I can actually have that. Okay, and public transfer. So here also I am giving some implementation. I'm going to give some implementation here. So I'm just writing the transfer success. Okay, some message actually, transfer success. Okay, that's simple actually. So now you have a specification. This is the specification, and now you have the implementation. So realization, a class implements interface. So for that, there is a keyword called implements. Public class SBI implements RBI. Okay, so now if you want to have the main method over here, just like the write the main here and create object. Which object? Which object? SBI object. So now I can create RBI object also. Interface is also a reference type. So RBI R1 equal to new SBI. So object created is of child, that is implementing class, and referred by the parent type, that is interface. So interfaces can refer to their implementation class object because it's a reference type. Interfaces can refer to their implementation class objects. Just like abstract class is referring to the child objects, interfaces also can refer to their implementation class objects, right? So with this particular R1, I can actually call all these methods. So withdraw method was there, and then R1 dot deposit method is there, and of course R1 dot yeah, so we have transfer method is also there. Okay, so usually we do like this because these all methods belong to RBI, not SBI, right? So that's why it's always better to refer with the parent type and call those methods. So if this class SBI has its own child specific method, like for example, it has a method, let's assume this method, and it says I'm SBI. So this you cannot call with R1 actually. So for that, what you require is an SBI reference actually. So SBI S1 equal to new SBI, because you cannot call a child specific method with parent reference, right? So S1 dot, I can actually say disk, right? Of course, this we have understood already. Fine. So this is how we can create an interface, and this is how we can actually implement an interface. Okay, this is the implementation of SBI. Now there can be another bank like HDFC that implements RBI and provides its own implementation. And there exists ICICI which implements RBI and provides its own implementation. So that's how loose coupling is achieved actually. No interdependencies. So now let me compile my SBI and run. So Java C SBI.java. Yeah, compiled successfully. And when I say Java SBI, now I will have withdraw method, withdraw success, and deposit method using the interest rate also. Deposit success and you got interest at 8.5. Transfer method, transfer success, and this method, which is a child specific method, we are calling with the child reference. So I am SBI, right? So that's simple actually. So there is a specification and there is an implementation. Specification is done with the help of interfaces, 100% of abstraction. Can also be done with abstract class where you have concrete methods and abstract methods. And the implementers are nothing but classes. So classes will implement these abstract entities, either abstract class or interfaces. So that's the basic concept of abstraction and how we do these implementations using abstract class and interface, okay, to specify the functionalities. I hope you have understood. So before I conclude, let me actually tell you one more point which I have given here. Interfaces can extend each other, right? Interfaces can extend each other. So there exists inheritance among interfaces also. Let me show you an example here. So interface printable, this is one interface I have. So you can actually, you want to make public, you can also make public interface printable, and it has a print method. And let me compile that one actually. Java C printable.java. Okay, so successfully compiled, and if you see printable, then you can actually see a public abstract void print. In the same fashion, I have showable. So let me make this also public. Even if you don't make public also, there is no problem. So the default within the package, they are available. And let me actually compile this showable also. Java C showable.java. And it's also properly compiled, and I can see the bytecodes as well. So now they have a show method. So now I have two interfaces. Okay, so but I would like to speak of inheritance, right? So now what can happen is public interface printable extends showable, right? So I have a showable interface which has a method called show. So now how many methods I have? Print method from printable and show method through showable. Okay, so now a printable extends showable. Showable has show method. Now any class that extends printable has the responsibility to implement both of them, right? So let's see that also. Let us assume I have a class. Okay, let us assume I have a class here. Otherwise, I will write a new class. That's better. A new class. So I just say public class A. I'm actually saving this as a.java. Yeah. So public class A implements what I'm saying, printable. When I say printable, printable extends. So this printable extends showable. Now printable extends is showable. Now it is the responsibility of this class A to provide implementation for these two methods actually, right? Void print and void show. Okay, so let me actually show you that. So now I am writing public. So we need not to forget public. So void public void print. So this is one implementation, and public void show. And this is the empty implementation. Okay, so now first check whether this particular thing is valid or not. So interface can extend other interface or not. Let's see. Yeah, so let me compile this printable Java C printable.java. Yeah, it's compiled. That means it's allowed, right? So now let's say Java printable, then see the bytecodes. Okay, Java P. It's not just Java pre-printable. Yeah, now you can actually see public interface printable extend showable, and you have the print method. From the showable, you have the showable method also. right? Because that class file is also available to you. So now my class A is implementing both of them, right? So let's write to see some output actually. So I'm just saying system.out.println. So it is printing, and so here I am saying PL. It's actually showing. Okay, so some LCD projector, it's showing, some printer is printing actually. So now when I give the names, right, printable, showable, so these are like adjectives. So always your interface name should be like adjectives. Okay, in the API, Java API also, we have some interfaces which are like serializable, runnable, clonable. So these are the some of the interfaces which are available in Java API. Those are like just adjectives. Okay, so now this particular class A implements printable. So now it is the responsibility of the class A to implement methods of printable as well as showable, because printable extends showable. Now I can create a main method. So here what I do is I can say printable. So now printable has how many methods? Two methods, because it extends showable also. So now I can say printable p equal to a new A, because this is the implementation class. The upcasting will happen here. So p dot print and p dot show, p dot int and p dot show. That's it, right? So let me compile this class A and see that it's getting executed. So Java C A dot Java. It's compiled successfully. When I say Java A, now you can see printing and showing. That's it. So this is about inheritance. So interfaces involve or participate in inheritance. So we know how to specify inheritance. So extends keyword actually. And whenever a class implementing that printable, it should remember that printable is extending showable. So it has to provide implementation for all abstract methods, right? So if it's not providing, then an error is going to come actually. Okay, so this is about interfaces. Very simple, right? Interfaces have all public members and will have only abstract methods and constants. It doesn't have any constructor. So we have seen, right, whenever we generated bytecodes, we didn't see any constructor. So no data members, that means variables, and no constructors, only abstract methods and constants. So hope you have understood, and see you soon uh, with the next session where we are discussing about some new features in the interface. Thank you.